All right, use the graph of each equation to test for symmetry with respect to the x-axis, y-axis, and the origin. Then confirm your answer algebraically. So we are most certainly going to confirm our answer algebraically for functions only. If it's symmetrical to the x-axis, you have to identify that, but you don't have to prove it algebraically. All right, here we go with problem 5. So if you notice, they highlighted some ordered pairs for us to examine in this example. They are symmetrical to the x-axis. I'm going to abbreviate. Also notice it is not a function. Also notice the y value is squared. Remember, if the y value is squared, it's not a function. All right, let's take a look at number 6. So for number 6, again, this graphic has some ordered pairs highlighted for us. Notice the scale is in increments of 2. So the ordered pair over here in quadrant 1 is 2, 2. The ordered pair over here in quadrant 3 is negative 2, negative 2. Notice they are exact opposites, both the x and the y. So if everything is opposite, this is symmetrical to the origin. And if it's symmetrical to the origin, you must associate it with being an odd function. Number 6 has 2 attributes. Symmetrical, I'm sorry guys, I won't know unless you tell me. Symmetrical to the origin and also an odd function. So real quick, let me just prove this algebraically for you. So down here, I'll show the proof. You just plug in the input and the output, and you're going to get a true number sentence, a true equation. So I'm going to plug in 2 and 2 for x and y, and that should equal 4, and it does. I'm going to do the same thing for the opposite. I should get a true number sentence, for sure I do. That's your proof from the picture. All right, let's take a look at problem 7. So for problem 7, y'all listen. All parabolas that have a vertex on the y-axis are always even functions. All parabolas that have the vertex on the y-axis are always even functions. We're going to prove it. All right, so for this, let's see. Let's use these 2 ordered pairs. So again, this ordered pair in quadrant 1. This is 2, 2. But in quadrant 2, it's negative 2, positive 2. So remember, the outputs are the same, and the inputs are opposite, that is an even function. It is for sure symmetrical about the y-axis.
Being prepared for a storm before it happens is the difference between weathering the storm.
For sure, an even function.
When the stakes are high, you need a battery that's built different. Duracell is built different to keep critical devices working when it matters the most.
Here's the proof.
Storm headed to Houston soon. Be ready with Duracell. Power you can rely on. Head to your local Walmart.
You plug in your input and your output, see if you get a true number sentence. I'm going to plug in 2, 2, so I'm going to replace the output with the output given. I'm going to replace the x with the input given. Is that a true number sentence? It is. This is a negative 4 plus 6. That's a true number sentence. Now I'm going to plug in the other ordered pair. The output is still 2, but this time the input is a negative 2. It still comes out to the same thing. So there's the proof.
Doubling the cash back you've earned at the end of your first year is what we do.
Well, I'm doubling everything now.
Okay, the next one that we're going to talk about is not symmetrical. I mean, it's not a function. So it's a circle. It's centered about the origin. Y'all, it is symmetrical to the x-axis, to the y-axis, and to the origin. But we really don't care that much because it's not a function. So this is symmetrical to all three. You do need to recognize it's symmetrical to x-axis, y-axis, and the origin. But it's not a function. Notice how the y value is squared. All right, now let's talk about when a picture isn't given, which is going to be test and quiz questions also. So if you could please turn to page 23. We're going to turn to page 23.